Good evening, everybody. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 Charlie Sierra Juliet in Narre Warren South. VK3EKH is broadcasting on prime frequency of 3541 kHz in the 80 metre amateur radio band, and simulcasting on 1865 kHz in the 160 metre amateur radio band on SSB, both modes SSB. We're also streaming on the YouTube Stream My channel, VK3CSJ, live in full HD, reasonable anyway. And we have also a active email address, vk3ekh@gmail.com, vk3ekh@gmail.com. If you wish to send reports tonight, signal reports on both 160 and 80 metres, that would be super. We also have a Discord chat window that's available for anybody wishing to come up for a regular chat with the other chaps that come up on the chat window. The chat window can be found from the ASV website at www.asv.org.au. Look for the Radio Astronomy tab and then look for the link to the ASV broadcast, Friday night ASV broadcast. And all will be revealed. The Discord chat window is via a little icon, Radio Astronomy icon link, and away you go from there. And as I look right now, I can see that we have Steve, VK3SBX, has joined, and also Richard, VK3VRS. Good evening, chaps. Welcome to tonight's session. All right, everything's been in a bit of a rush tonight. As usual, I compose everything in the last couple of minutes, but I think we've got a reasonable show tonight, if you can call it a show. A very pleasant good evening to an old friend of mine I haven't seen in years, Sydney Edwards. G'day, Sid, if you're listening and watching there on the wide 65 centimetre screen, I think it was. Good to see you up and about, and haven't heard from you for ages, so be great to catch up and see what's been happening. Anyways, all right, let's just get into the usual blurb for the ASV for those that are joining for the first time. Of course, the ASV radio has been, well, VK3EKH has been broadcasting since 1988, and of course, except for the occasional Fridays that I decide to have off. Of course, Russell Ward used to run the program since 1988 for the first 20 years. Russell Ward is VK3DRW, and Russell used to operate the station for those first 20 years before taking a sabbatical, and in which case I took over the microphone and been doing it ever since. The Melbourne television repeater is still off air as I speak. Melbourne VK3RTV digital channel 1 and 2, it's still currently down. And I know that Peter, VK3BFG, is working his little heart out trying to get the repeater back up and running. So hopefully, maybe by this time next week, we might have something up and running again on the Melbourne TV repeater. The Astronomical Society of Victoria was founded in 1922. It comprises well over 1,600 members throughout Victoria, including various other states of Australia and overseas. Membership of the Society, of course, is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mullier Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the extensive library located at the Melbourne Observatory. Receipt of the ASV magazine called Crux, which contains articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try it before you buy. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger to only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is an 8.5 fully steerable radio telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes, of course. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. And I think this week I might just run through all the sections instead of just the handful that's in that article. There's 20 sections that make up the ASV these days in alphabetical order. It starts off with astrophotography, probably the biggest section out of all of them. Astrophotography, Bendigo section, the club section, comet section, computing section, cosmology and astrophysics, deep sky, demonstrator section, diurnals, Great Melbourne Telescope section, historical section, instrument making, juniors, lunar and planetary, meteor section, new astronomers group, outdoor lightning improvement, radio astronomy, solar and space exploration. And of course the space exploration, it would be absolutely rocketing off at the moment with the recent launch of Artemis. So I suspect that they're doing absolutely great, that little section at the moment, which is directed by Katie Green. So I know she's been posting a lot on the Facebook page lately too. Anything to do with space exploration, she's posting articles and links to various things almost immediately. And of course the Artemis has been the key thing at the moment, which I'll have a little story we'll catch up on in tonight's news. All right, so like I say, all those sections, if you go to the ASV website at www.asv.org.au, all those sections are presented under the sections tab at the top of the window, and there's a little pull down box which shows all those sections. Each section is its own individual page when you click on it, and more information can be revealed about those sections. And if you are interested, you don't have to be a member at first. But if you are interested in any of those particular sections, you just contact the section director if you want to ask to sit in on a meeting, and you'll be more than welcome to come in and have a look at what's going on. And then, of course, the section director will be obliged to inform about how to become a member of the ASV as such. And, of course, all that can be found from the homepage of the ASV under where it says membership. Click on that. And all the information about becoming a member of the ASV is just there. It's all done via PayPal, and it's easy peasy Japanesey. So all good stuff. Cup of coffee. I don't think it's the first. It might be the first one for the day. Anyway, righto, Mr. Brash. Where was I? So we're talking about the ASV, and that's about it. I think I've devoted the first 10 minutes of the program to all that. So, like I say, more information can be revealed if you go to the ASV website at www.asv.org.au. Probably the biggest society, amateur society in Australia, in the Southern Hemisphere, most likely. All right. No, I don't want that. Where are we next? Coming up to Struth. Sky Notes. Now, I'll just run through a few dates that I didn't say last week. Today's the 18th, so let's see where I can kick off from. Courtesy of Tanya Hill at the Planetarium. All right, from the 16th. The 16th of November 1974, the first radio message sent into space, USA, Puerto Rico, the Arecibo message to star cluster M13 at 25,000 light years away. Took 3 minutes to send the message. It didn't take exactly 3 minutes to get to the cluster. It's just the kind of way that reads, but no, it's a 3-minute message. It was 1,679 binary bits, ones and zeros, arranged in 23 columns and 73 rows, which reveal visual information. Primary numbers 23 by 73, 16, which equals 1679. And that was the 16th of November 1974. The good old Arecibo telescope was used as a transmitter to beam a signal to M13, which would be still on its way. Oh dear. On the 17th of November 1970, Lunar Hod 1, I think that's how you pronounce that, Lunar Cod, perhaps it's Russian, or Moonwalker USSR, was the first remote-controlled moon rover delivered by lander, Luna 17. It drove 10 kilometres and lasted 321 Earth days, far longer than expected, the 3 months. On the 20th of November 1998, the first module of the International Space Station, Russia's 12-metre Zyru or Sunrise functional cargo block, is launched, beginning a multi-mode, multi-year assembly of the space station in low Earth orbit, 1998. On the 26th of November 2012, Curiosity rover arrives in Mars's Grail crater after a high-speed entry and first use of an innovative final landing technique, the sky crane. And how successful was that? On the 27th of November 1971, first probe to reach the Martian surface is Mars 2, USSR, although it crashes in the process. Also on the 27th of November 2001, the first detection of the composition of exoplanets' exoatmosphere by the Hubble telescope for planet Osiris, OSIRIS, orbiting a sun-like star 150 light years away. And the last date I'll use here, the 29th of November 1967, Australia becomes the third nation after USSR, USA and France to launch a satellite from its own territory. It was a 45-kilogram WRESAT, WRESAT Sat-1, or Weapons Research Establishment Satellite, which made 642 polar orbits until re-entry 11 days later. How about that? And I'll throw in one more date. The 30th of November 1609, Galileo studies the moon with his improved telescope, and while not the first to do so, he was the first to explain mountains and craters and chart lunar features and their heights. Magnificent stuff. And I'm going to throw in the last date here. The 30th of November, also the 30th of November 1954, Anne Elizabeth Hodges of Alabama, USA, becomes the first person injured by a meteorite. And I've got a bit of a story on that tonight. Not this particular one, though, but another one. Anne Elizabeth Hodges of Alabama becomes the first person actually injured by a meteorite. She was badly bruised by a 5-kilogram rock that crashed through her roof, deflected off a radio cabinet, and hit her while she was asleep on the couch. That just goes to show you should not go to sleep during your favourite program. This is ASV Radio, VK3EKH, coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening to one and all. Okay, we have an email address. If anybody wishes to send an email tonight on tonight's broadcast, vk3ekh@gmail.com is what's being used. And I am looking at the inbox as I speak, and I can see that we have a email. Using the wrong mouse. Where is that mouse? Come on, mouse. Wake up, mouse. From Stuart, VK3UAO. He says, good evening, Clint. Good copy on 80 metres here in northern suburbs of Melbourne. So thank you, Stuart. And there was one other there, I see. Stephen, he says, this is XPX, VK3SPX. Great signal on 80 metres here in Burriup, 125 kilometres northwest of Melbourne. Thank you, Steve. So there it is. It's, I know the evening's early. All right, so we have also Rob, VK3XRA, has joined our chat window, and Remus also has joined. G'day, Remus and Rob. I think that's it there. That's all that's come up so far, I think. Anyway, all right, next article is about one I left over from last week. Saturn's moon Enceladus may be more habitable than we first thought. And I do have an image here that I can bring up. Let me just focus on that. There it is. Okay. New research suggests that subsurface soda ocean on Saturn's moon could increase the availability of phosphorus, a key ingredient for life as we know it. And that image you're seeing there, this is the artist's concept shows the plumes of ice particles erupting from fractures in the solar south polar region of Saturn's moon Enceladus. In our solar system, Saturn's moon Enceladus is unique. It provides scientists direct access to a global ocean hidden beneath the moon's icy surface. And that's because Enceladus is constantly venting its subsurface water into space. Numerous geysers spew water vapor hundreds of miles into space through cracks that seem clawed into the moon's south region, polar region. During its flybys, the Cassini spacecraft tasted some of the plumes, and its analysis indicated that the water may have come from a carbonite-rich subsurface ocean. A few of the plume's contents, salty ice particles, ammonia, carbon monoxide, and other organic materials, strengthened the case for the potential habitability of Enceladus's ocean. However, Cassini's analysis did not reveal phosphorus, a key ingredient for life. But now a group of researchers have for the first time estimated the presence of a form of phosphorus called osphosphate. That's a nice long word, which Earth life uses in many contexts. The researchers also found the phosphorus is both highly soluble and stable in Enceladus's salty subsurface ocean. The researchers published their findings on September 19 in the Proceedings of the National Academy of Sciences. There's another image here. I wonder if I save that. Oh yeah, I did. There it is. Okay, I'll bring that up. And I think this might be a real image. Enceladus plumes are seen erupting from the famous tiger stripes near the moon's south pole in this image captured by Cassini. The spacecraft's survey of Enceladus ultimately revealed more than 100 geysers. So that's a real image. They're real geysers being forced to come forward from the surface of Enceladus. They're most interesting to see. The study's authors performed geochemical modelling constrained by the Cassini data to predict how much phosphorus could be present in Enceladus ocean. They found that the ocean water should be rather rich in dissolved phosphoruses, lending credence to the notion that the moon's subsurface ocean could be a habitable environment. The most interesting and promising aspect of this work is that the abundance of phosphorus may be quite high in the ocean of Enceladus, anywhere from 0.1 to 1,000 times that of Earth's oceans. The chemical reactions that generate the energy currency in cells are and build RNA and DNA are crucial to the functioning of every living organism. And while these reactions require phosphorus, the mineral is relatively scarce in natural waters because it reacts with cations, positively charged atoms or molecules such as calcium, to form calcium phosphate. That reaction makes the phosphorus inaccessible for use by potential life. The key to abundant availability of dissolved phosphorus in Enceladus oceans is that it has a soda ocean, which is rich in sodium bicarbonate, or a baking soda. Christopher Glean, a planetary scientist and geochemist at the Southwest Research Institute, and one of the study's authors, told Astronomy. And there's another image here that I can bring up too from this article. Just bring that up. There it is. And that one there it's based on Cassini data. This illustration shows how researchers think water might interact with rock at the bottom of Enceladus' subsurface ocean, just to give you a bit of an idea. As important as phosphorus is, it's only one piece of a fascinating puzzle when it comes to the habitability of Enceladus. Sulfur, for example, is another important ingredient for life as we know it, but scientists are currently unsure how much sulfur is in Enceladus' oceans, as well as the chemical forms it may take. The biggest obstacle in finding out, according to Glean, is limited data. We have a wonderful data set from Cassini, and folks are still searching for treasures in those data, he says. I think we still have some exciting discoveries that await us. In the long term, we are going to need more data to really understand Enceladus as a geochemical system, and, of course, to test for the presence of life. When the ocean trapped underneath Enceladus' icy surface was first discovered, it added an intriguing option to the list of potential habitable environments where life could exist. Future missions would undoubtedly benefit from visiting the Moon's south polar region, where the plumes bursting through the surface provide unfiltered access to the subsurface ocean. And fortunately, such a mission is already in the works. NASA's Enceladus orbital lander, currently a flagship mission concept with a stated launch in the late 2030s. Orbital lander will focus on hunting for signs of life on the Enceladus from orbit, at least at first. Right, so Enceladus will be definitely a very interesting moon to study for further in the future. Watch this space. That's if I'm still transmitting in the 2030s. Probably not. All right, next article. This is ASV Radio, VK3EKH, coming to you from the studios of VK3CSJ. Oh, it's a little bit on Artemis. And I've got some vision for that, which is, where is that vision gone? I did upload it. I'm sure I put it onto vMix. Oh, there it is. It's dark, that's why. Okay. I think there will be audio associated with this, but I don't think I'll worry about the audio. What I'll do is I'll just loop it, because it only goes for less than a minute, this footage, I think. And I've got just a little bit of an article to read, so run
and
that.
And liftoff of Artemis 1.
And
we rise together, back to the moon and beyond.
NASA's Artemis 1 moon mission, the agency's first big step towards returning astronauts to the lunar surface, launched to the moon on November 16, lifting off at 1:47 a.m. EST, or 06:47. Don't worry about that. Launch Complex 39B at NASA's Kennedy Space Center in Florida. Open the video above. Oh, it's telling me to open the video. Don't worry about that either. Artemis 1 is the first test flight of the agency's new space launch system, Mega Rocket, and the Orion crew capsule. The SLS rocket launched the uncrewed Orion spacecraft on a approximately 42-day mission, during which it will orbit the moon before returning to
and
Earth.
liftoff of Artemis 1. We
while
rise
you're down.
together.
That's all they say
Back
about
to
that.
the moon and beyond.
Oh, well, I think we all know that. So I'll see if I can find out more information on that. But anyway, I'll run the footage just a little bit longer here. There's some very interesting video here which I didn't see on the launch on Tuesday night. I think it was Tuesday. And like this one here with the camera on the outside of the rocket as it takes off. I didn't see that. They didn't show that in the initial footage. But there it is there. There's definitely some very great angles on this rocket taken off, and it really is quite amazing. It's a pity it wasn't during the day, but I was saying go.
We rise together.
And I think a
Back
lot of
to
other
the
people
moon
are saying the
and
same
beyond.
thing. So this will be very, very interesting to see how well it all works. It will be great to see back on the moon in the next couple of years or so. All right, now the next thing I have here is to do with a little bit on my black hole, and I've got an image for this too. What the image of the Milky Way black hole really shows. The massive object at the galaxy centre is invisible, but this year's picture of a swirling plasma around its edges will help to reveal more about the galaxy's history and evolution. I don't think I'll read the full article out. I might. It just depends on how much I can go with this before falling asleep. Okay, I'll just run this GIF image, and I think it's on a loop. It's not on a loop now. Alright, so what this is all about, to create the first image of the Milky Way's black hole, scientists ran numerous simulations of the swirling envelope of plasma that encircles it. This clip shows the version of the animated computer model that seemed to best mirror the radio wave data collected by the Events Horizon telescope. Black holes keep their secrets close. They imprison forever anything that enters, and light itself can't escape a black hole's hungry pull. It would seem, then, that a black hole should be invisible, and taking a picture is impossible. So great fanfare accompanied the release in 2019 of the first image of a black hole. Then, in spring 2022, astronomers unveiled another black hole photo, and this time the one at the centre of our own Milky Way. The image shows an orange donut-shaped blob that looks remarkably similar to the early picture of a black hole in the centre of galaxy Messier 87. But the Milky Way's black hole, Sagittarius A, is actually much smaller than the first one and was much difficult to see, since it required peering through the hazy disk of our galaxy so even though the observations of our own black hole were conducted at the same time as M87's, it took 3 additional years to create the picture. Doing so required an international collaboration of hundreds of astronomers, engineers and computer scientists, and development of sophisticated computer algorithms to piece together the image from the raw data. And there's another image I'll bring up here, this fella. What we're seeing here is the atomy of a black hole, the Milky Way Sagittarius A. The reference to the picture here is that the new image of the black hole Sagittarius A confirms and refines previous predictions of its size and orientation. The mass of the black hole determines its size, or what scientists call its gravitational diameter. The point at which no light can escape from the black hole, called the event horizon, is determined by this mass and by the spin of the black hole. Hot plasma speeds around the massive object in the accretion disk, emitting radio waves. Those radio waves are bent and warped by gravity, though the effect of gravitational lensing to produce the image of the orange outer circles. The black hole shadow and emission ring shown here are gravitationally lensed projections of the far side of the black hole's event horizon and accretion disk respectively. So it's kind of gives you a bit of an idea what's going on. These photos do not, of course, directly show a black hole, must be stressed. Defined as the region of space inside a point of no return barrier known as an event horizon, they actually record portions of the flat pancake of hot plasma swirling around the black hole at high speeds in what's known as the accretion disk. The plasma is composed of high-energy charged particles. As plasma spirals around the black hole, its accretion particles emit radio waves. Blurring orange rings seen in the images are an elaborate reconstruction of these radio waves captured by 8 telescopes scattered around the Earth, collectively known as the Event Horizon Telescope, or EHT, Extreme High Tension. Oh, sorry, that's something else. Event Horizon Telescope. The latest image tells the tale of the epic journey of radio waves from the centre of our Milky Way, providing unprecedented detail about Sagittarius A. The image also constitutes one of the most important visual proofs of general relativity, our current best theory of gravity, says Sarah Markov, an astrophysicist at the University of Amsterdam. Studying supermassive black holes such as Sagittarius A will help scientists learn more about how galaxies evolve over time and how they congregate in vast clusters across the universe. There is a lot more to this article. I'm sort of nearly finished. Yeah, all right. From the galactic core, and I'll come back to my camera. Where's my camera? Camera. Oh, come on. Here we are. Okay. Back to the article. From the galactic core, Sagittarius A is 1,600 times smaller than Messier 87's black hole that was imaged in 2019 and is also about 2,100 times closer to Earth. That means that two black holes appear to be about the same size on the sky. Jeffrey Bauer, an EHT project scientist at the Academia Sincere Institute of Astronomy and Astrophysics in Taiwan, says that the resolution required to see Sagittarius A from Earth is the same as it would be required to take a picture of an orange on the surface of the Moon. The centre of our galaxy is 26,000 light years away from us, so the radio waves collected to create this image were emitted around the time that one of the earliest known permanent human settlements were constructed. The radio waves voyage began when they were first emitted from particles in the black hole's accretion disk. With a wavelength of about 1 millimetre, the radiation travelled toward Earth relatively undisturbed by the intervening galactic gas and dust. If the wavelength were much shorter, like visible light, the radio waves should have been scattered by the dust. If the wavelength were much longer, the waves would have been bent by charged clouds of plasma, distorting the image. Finally, after the 26,000-year trek, the radio waves were picked up and recorded at the radio observatories distributed across the planet. The large geographic separation between the observatories was essential. It allowed the consortium of researchers to detect extremely subtle differences in the radio waves collected at each site through a process called interferometry. These small differences are used to deduce the minuscule differences in the distance each radio wave travelled from its source. Using computer algorithms, the scientists managed to decode the path length differences of the radio waves to reconstruct the shape of the object that emitted them. And there's a little graphic here that shows how this is sort of done. Which I shall bring up. There it is. And what you're seeing there is the latest black hole image was created using a technique called interferometry, in which radio waves emitted by the black hole and the collected by eight telescopes located around the world are compared. If two sites collect waves that were in phase, meaning the waves' peaks lined up with one another, then the two waves would add together to create a bright spot on the image. If, on the other hand, the waves were out of phase, meaning that one wave's peak lined up with another's trough, the waves would cancel each other, producing a dark spot in the image. Working together, the telescopes are able to collect more detailed data than one could alone. Researchers have put all these into a false colour image, where orange represents high-intensity radio waves and black represents low intensity. But each telescope only picks up a tiny fraction of the radio signal, explains one of the scientists, astrophysicist at the University of Arizona, who has written about our galaxy's supermassive black hole. Because we are missing much of the signal, instead of seeing a crystal clear photo, you see something that's a little foggy and a little blurred, he says. The image helps reveal more about the black hole's event horizon, the closest point to which anything can approach the black hole without being sucked in. Beyond the event horizon, not even light can escape. Yeah, we all know that. From the image, scientists have been able to better estimate the size of the event horizon and deduce the accretion disk is tilted by more than 40 degrees from the Milky Way's disk, so that we're seeing the round face of the flat accretion disk rather than the thin sliver of its edge. And I might just go back to that little GIF image that I've got here, which was pretty cool to look at. Okay, and this is what they're referring to. But even if the black hole's accretion disk were orientated edge-on relative to the Earth, the gravity around the black hole warps the space around it so much that light emitted from the backside of the black hole would be bent around to come towards us, is what I'm trying to say, making a ring-like image regardless of its orientation, which you can see in this image. So how do scientists know its orientation, you might ask? Because the ring is mostly round, if we were viewing the accretion disk edge on, then the ring would be more squashed and oblong. Markov thinks that this new ability to look into the heart of our galaxy will help to fill in gaps in our understanding of the evolution of galaxies and large-scale structure of the universe. A dense, massive object such as a black hole at the center of the galaxy influences the movements of the stars and the dust near it, and that influences how the galaxy changes over time. Properties of the black hole, such as in which direction it spins, depend on the history of its collisions, which stars or other black holes perhaps. A lot of other people look at the sky and think it's all as static, right? But it's not. It's a big ecosystem of stuff that's evolving, Markov says. So far, the fact that the image matches the scientists' expectations so previously makes it an important confirmation of current theories of physics. This has been a prediction that we've had for 2 decades, Bauer says, and that we would see a ring of this scale, but seeing is believing, he says. All right. Okay, so if you want to catch up with that article, courtesy of Australia, of astronomy.com, look under the news tab for what the image of the Milky Way's black hole really shows. All right. At about 20 minutes to 11, you're tuned to ASV Radio. Excuse me. The regular broadcast coming to you from the studios of VK3CSJ in Narre Warren South. We're broadcasting on 3541 kilohertz and also on 1865, and also our YouTube channel where I'm putting up all the visions and pictures that are associated with the articles. Unfortunately, there's a bit of a delay associated with the YouTube stream as opposed to what you're hearing on HF Direct. Can't do much about that. So it's either one or the other. or turn the sound down on YouTube and just listen to me here with all the crashes, lightning crashes and static and noise. Enough of that. Okay, next. Done that. Oh, yes. We're coming up to Timothy's solar report. Stand by for Timothy's solar report in just a few minutes. I've got an image here to show of this article, and I shall bring that up. Where are you? It's just a little image here. Oh, there it is. Okay. You might ask, what is this? Okay. For those watching the visions, if you think, start again. If you could shrink down to the size of an atom, what would you see? Question mark. While the quantum world is all around us, shrinking down to the size of an atom to experience this strange realm would be difficult for humans. And this is November 8, 2022, courtesy of Astronomical. In 2022, 3 physicists won the Nobel Prize in Physics for their work on spooky quantum entanglement. Some quantum seekers now envision having a Halloween party in the subatomic world. There, they hope to experience firsthand the weird quantum effects that have long stoked their imaginations. But what would the subatomic world look like and feel like, and how would you get there? Question mark. The quantum realm. Well, the good news is the quantum world is not far away. We live in it. The theory of quantum mechanics describes the entire universe, including the everyday world we are familiar with. However, at the micro or macroscopic level, the weird quantum effects are relatively weak and hard to perceive. To readily experience quantum weirdness, a human would have to shrink to about the size of an atom, says Jim Kalilos, a physics professor at the University of Minnesota. The problem with that is all atoms are about the same size and cannot themselves shrink. Humans are composed of about 7 octillion atoms, and all those atoms would have to cram into space the size of one atom. A shrunken human would be unimaginably dense. Right. So, continuing on. Humans would have to figure out some way to alter the fundamental constraints of the universe to change the size of their atoms. There's no way to do that, says Kalos. It's one of these guys got a strange name. Kalos, that'll do. But what if you did manage to evade the laws of physics and shrink to the size of an atom? Which, you can do in science fiction films easy enough. When you're down to that size, your interactions with light will be very different from what you usually see. Our eyes could detect single photons. Everything would be kind of staticky and weird instead of like continuous stream. Single protons of light would strike your eyes like rain on a tin roof. How you would be able to process that is very hard to say. 2 human eyes might compare to a scientist Thomas Young's double-slit experiments from the early 1800s, which are famous for leading us down the road of quantum mechanics. In the experiments that were revisited in 20th century, scientists sought to determine whether a light is a wave or a stream of particles, and found that light in fact acts as both a wave and a stream of particles. In